Okay, so in this ISP task, we're going to cover part 5 of Unit 1 materials for Edexcel Physics. Is a final task as part of this ISP, and it's essentially just a summary of all the work that you've covered so far, answering questions 14, 15, 16, 17, so 4 questions from the back of the ISP. Those of you that are aiming for an A or an A star, you should really at this point make a list of all the materials and the mechanics topics and start to try to link the ideas together. So I've tried to do one for you here in terms of terminal velocity and forces. So remember, we've done terminal velocity in here, we've done about forces in mechanics, and you should be able to make links between the two. So try to find some other links as well, and some of them have been sort of mentioned above, like stress and strain and equilibrium and work over here. Stress and strain and equilibrium, and the idea of work and air resistance and Stokes law further up. Okay, so let's skip straight into the questions. Not on mine, skim the questions. Okay, so here we go. Task 5, question 14. Point B, okay, so that's the limit of proportionality, okay, so after that, no longer proportional. State the physical property represented by the gradient of section B of this graph, okay, so it's force against extension, that's therefore going to be the stiffness of the sample. Explain the significance of the area under the graph between A and C. Let's see, energy stored before failure, energy stored before it actually breaks. So nice starter for 4 marks, okay, let's double check that. Okay, so proportional or Hooke's law limit. It's a proportional limit, like I said, stiffness, okay, of the sample or work done to stretch the white effect check. It's work done to before it actually breaks. Exactly the same idea. Brilliant. Okay. Question 15. Question 15. Here we go. Skydiver accelerates towards the ground, 9.81 meters per second squared. Okay, so sorry about that not being in superscript like it should be. At the instant he leaves the airplane. Explain why this acceleration will decrease as it continues to fall. So remember, he's getting faster. So remember, the whole idea with terminal velocity is his velocity increases, which means his air resistance increases, which means the resultant force decreases, which means his acceleration decreases. Okay, that is the basic property behind terminal velocity. As he falls, his velocity is going to increase, which increases air resistance until, remember, it is equal to until that at the up thrust is equal to weight. So this causes his resultant force to decrease, which therefore causes acceleration to decrease. Okay, that's the first part of it. Skydiver opens his parachute. Explain why his terminal velocity, why he reaches terminal velocity afterwards. Okay, so remember, in this situation, what happens is all of a sudden a massive increase in air. So when he opens the parachute. Okay, so he opens his parachute. Let's draw a little line. As he does that, okay, the air resistance massively increases. Rapidly would be a better word. Rapidly increases. Okay, let's use rapidly, not massively. Rapidly increases, and then it is equal to weight, which therefore leads to terminal velocity. So the velocity at which he hits the ground is similar to those achieving when free falling from a height of 3 meters. Calculate this velocity. Okay, so this actually isn't materials work, it's mechanics. So that's why I've asked you to make a link back to your mechanics work as part of the AA star task. So AA star students should really be able to nail this question. It's actually pretty straightforward. So the distance is 3 meters. Initial velocity saying free fall, falling freely from a height of 3 meters, so the initial velocity is going to be 0. Final velocity is what we want. Acceleration is minus 9.81 or 9.81 if you're just taking down as the only direction involved in this, which it is, meters per second squared. And there we go, we don't know anything else. Well, we know an equation for this is v squared equals u squared plus 2as. Well, hold on, u is equal to 0, so that's going to disappear, so you end up with v squared is equal to 2as. Therefore, v is equal to root 2as. So let's work that through our calculator. So 2 times 9.81 times 3, s is 3, because our displacement, and then we get a square root of that answer. Okay, so it's about 7.67 meters per second. That's how fast they're going at the end of this, 7.67 meters per second. Okay. So we've got a sign on the, oops daisy, that's just the previous video. No, I don't want to do it now. Let's move back across. Okay, so we've got a sign on the edge of a platform. And it says, what is meant by turbulent flow? Okay, and suggests why it's dangerous for passengers to stand near the edge of the platform. So keep back from the edge of the platform. Passing trains may cause risk of air turbulence. Okay, so remember, turbulent flow is flow with the mixing of layers. Okay, abrupt changes of direction. So because of the turbulent flow taking place, because there's abrupt changes of direction, that could cause, and walls are set up or eddies are set up, this could cause a passenger to be sucked in off the edge of the platform and fall under the train and get hurt. So let's check questions 15 and 16. Okay, Skydiver speeds up. This is exactly what I was talking about before. Skydiver speeds up, causing air resistance to increase. So net force will decrease, or resultant force will decrease, reducing acceleration. So exactly what we said. Parachute greatly increases the size of air resistance, or rapidly increases the size of air resistance. So when air resistance is equal to weight, is at equilibrium. That's exactly what we're talking about. V squared equals U squared plus 2AS. Correct answer 7.7 or 7.67 is fine. Brilliant. Okay. So 16 is a quality of written communication question. It's got mixing of layers, exactly as I discussed. Okay, which causes air to circulate near the edge of the platform, just like a sense of passengers may be pushed over due to edges of walls, again like we discussed. Okay, so it's 3 clear marks on there. Okay, 17. So question 17, okay, is asking about a raindrop. It's got a set diameter, set radius of 0.7 millimeters. So remember that is 0.7 times 10 to the minus 3 meters. Okay, it's falling at terminal velocity. Show that the mass of the raindrop is 1 times 10 to the minus 6, and the density of water is this. Okay, so we've got density is equal to mass times by volume. No, sorry, let me get that right. Mass is equal to density times by volume. We know the density is 1,000. We know the volume, if the raindrop, assuming it's spherical, is 4/3 pi r cubed. This will be 1,000 times by 4/3 times pi times 0.7 times 10 to the minus 3 cubed. Close the bracket off. Let's put it through here. So 4, oops, let's put it in the middle. I haven't shown my working there. There we go. Pause the video if you need to at this point before I carry on with the calculation. Okay, so it's 4/3 multiplied by pi, delete pi times 0.5, 0.7, sorry, 0.7 exp minus 3 cubed. That's the volume times by 1,000. Okay, so 1.4 times 10 to the minus 6. Exactly what I said, about 1 times 10 to the minus 6. Perfect. Okay, so figured out what the mass of it is there. Right, so ignoring any upthrust on the raindrop, calculate its terminal velocity, and you've got the viscosity of air there. Okay, so if you're ignoring upthrust, calculating terminal velocity is straightforward. Let's use the bottom of this sheet over here instead of wasting a new piece of paper. Okay, so if we're ignoring so normally if we've got a falling object, weight is equal to viscous drag plus upthrust. Okay, we're ignoring upthrust, so we're saying weight is just equal to viscous drag. So weight is mg. Viscous drag is 6 pi r e to v. Okay, they want to show what the terminal velocity is, so we need to rearrange for v. V is going to be equal to mg over 6 pi r e to v. Well, we have all those values. Okay, we have m, we just figured it out in the last question. I mean, mine was 1.4 times 10 to the minus 6. I'd rather use that than the 1 times 10 to 6. Remember that 1 times 10 to the minus 6. Remember, they don't mind which you use as long as because they'll have both in the mark scheme. So either one of the ones that you've calculated or the one that was the one they gave, which is 1 times 10 to the minus 6. Well, I'm going to use my 1.4. We divide it by 6 pi. R is going to be 0.7 times 10 to the minus 3. Eta of viscosity is 8.9 times 10 to the minus 4. And that's it. I've put V in there twice when I shouldn't have. I'm going to rearrange that V shouldn't be there. Okay, so to work that through and figure out what we get. Okay, so instead of typing that through my calculator, I'll just show you that they've done that on the mark scheme. So you can see they've done it here exactly as I've just said, except they use 1.44 rather than 1.4, and they multiply it through and with 1.2 as your answer. Okay, so that's the end of task 5 and also the end of the materials ISP. I hope you felt you've learned something from this ISP. I hope you feel that you're confident to answer questions on this area. I would say the most difficult area on this is about the idea of terminal velocity. It's the bit at the start where you have to rearrange equations for terminal velocity. The bits that you really, if you're a hard slogger in terms of your work and you like to put the effort into to really sort of like feel like you're learning something, then go away and definitely learn the definitions. I mean, one of the things I'll do with those definitions for like words like brittle and whatnot is on one piece of card on one side write the word brittle, on the other side write the definition of what it is, lay them all out, and sort of like every evening just make sure you choose 3 and you can definitely rattle off what a definition is, and don't let yourself go to sleep until you get the 3 of them right. I'm not advocating sleep deprivation. What I'm saying is it's a good technique to get you guys to revise. I mean, you learn it after doing maybe 2 or 3 minutes of it. So making sure you know those definitions is absolutely key. Don't walk into the exam not knowing what those words mean. If you don't know what words I'm on about those words right there, okay? Do not walk into the exam not knowing what these words mean. If you honestly you don't know what to do to revise, learn these words, okay? Because at least 2 or 3 of them will turn up in the exam. Okay, so thank you very much for all your hard work, guys. Keep it up, and I hope you enjoyed this video. Oops, is this the wrong slide? There we go. I hope you enjoyed this video on materials. Thank you very much, and thank you for listening.